Oreo cookies may look like a simple combination of two chocolate wafers and a white cream filling. But behind every perfectly aligned cookie is one of the most advanced, high-speed food manufacturing systems in the world. Produced by the billions each year, Oreos rely on massive automated production lines that blend raw agricultural ingredients, precision baking technology, robotic handling, vision inspection, and non-stop packaging systems capable of operating around the clock. What appears to be a humble snack is actually the result of extreme consistency engineering, food science, and industrial-scale efficiency designed to ensure every Oreo tastes, looks, and feels exactly the same no matter where it's made. And today on the How Factory, we're going deep inside mega cookie factories to see exactly how Oreo cookies are manufactured from raw ingredients to sealed packages ready for global distribution. The journey begins with raw ingredients arriving at the factory in bulk quantities. Flour, sugar, cocoa powder, vegetable oils, leavening agents, salt, and flavorings are delivered by tanker trucks, rail cars, or palletized shipments. These ingredients are stored in massive silos or climate-controlled storage rooms designed to protect them from moisture, pests, and contamination. Before entering production, every ingredient is tested for quality, particle size, moisture content, and consistency. Even small variations can affect dough behavior, baking performance, or final texture, so strict quality control begins before mixing ever starts. Dough production is the first major manufacturing stage. Industrial mixers, some large enough to process thousands of kilograms per batch, combine flour, cocoa powder, sugar, fats, and liquid ingredients into a dense, dark dough. These mixers use carefully programmed speeds and mixing times to develop the correct structure without overheating the dough. Temperature control is critical because excessive heat can alter fat behavior and weaken texture. Sensors continuously monitor dough consistency, viscosity, and temperature, adjusting mixing parameters automatically. Once mixed, the dough rests briefly to allow hydration and uniformity before shaping. From the mixers, the dough moves onto forming lines. High-pressure extrusion systems push the dough through shaping dies that form the iconic Oreo wafer discs. Rotary molding machines press the dough into patterned molds that imprint the familiar Oreo design, logos, and decorative edges. Excess dough is trimmed away and recycled back into the system, minimizing waste. The formed wafers are transferred onto long conveyor belts that feed directly into industrial baking ovens. Baking is one of the most critical steps in Oreo production. The ovens used are continuous tunnel ovens that can stretch hundreds of feet long. As the wafer discs travel through the oven, they pass through carefully controlled temperature zones. Initial zones set the shape and expand the dough slightly, while later zones drive off moisture and develop the wafer's crisp texture. Baking times are measured in minutes, but precision is everything. Underbaked wafers remain soft, while overbaked wafers become brittle and bitter. Computer systems monitor oven temperatures, airflow, humidity, and belt speed in real time to maintain perfect consistency. As the wafers exit the oven, they are fully baked but extremely fragile. Cooling tunnels immediately reduce their temperature to stabilize structure and prevent breakage. Cooling must happen gradually. Rapid temperature changes can cause cracking or warping. Fans and airflow systems gently bring the wafers down to room temperature while maintaining alignment on the conveyor. While wafers are baking and cooling, the cream filling is produced in parallel. The filling is made from a blend of sugar, vegetable fats, flavorings, and emulsifiers. Large mixing tanks whip these ingredients together under controlled conditions to produce a smooth, stable cream with a specific density and texture. The cream must be soft enough to spread easily but firm enough to hold its shape once sandwiched between wafers. Temperature control is critical here as well. Fats must remain within a narrow range to avoid separation or graininess. Once wafers and cream are ready, the process moves to one of the most impressive stages: sandwiching. High-speed assembly machines align two wafers with extreme precision. A measured dollop of cream is deposited onto the center of one wafer using synchronized nozzles. The second wafer is placed on top and gently pressed down to spread the cream evenly. These machines operate at astonishing speeds, assembling thousands of Oreo cookies every minute. Vision systems verify alignment, cream placement, and wafer integrity in real time. Any cookie with misaligned wafers, cracked surfaces, or missing filling is automatically removed from the line. After sandwiching, the cookies move through stabilization conveyors that allow the cream to settle and firm slightly. This ensures the cookies maintain their structure during packaging and transport. At this stage, additional inspections occur. Cameras check thickness, diameter, and color consistency. Weight sensors verify that each cookie meets specification. Consistency is paramount. Consumers expect every Oreo to look and taste identical. Next comes packaging, another highly automated operation. Finished cookies are guided into precise stacks using robotic arms or synchronized conveyor systems. These stacks are then wrapped in protective inner packaging that maintains freshness and prevents breakage. Plastic films or foil laminates are heat-sealed around the stacks, creating airtight packs. Packaging machines operate continuously, matching the speed of the baking line so production never slows. Wrapped stacks move to secondary packaging, where they are loaded into branded boxes, trays, or multi-packs depending on the product format. Robotic packers place wrapped cookies into cartons with millimeter-level precision. Each package is weighed and scanned to ensure correct count and integrity. Barcodes, expiration dates, and batch codes are printed for traceability. Any package that falls outside specification is rejected automatically. Behind the scenes, quality assurance teams monitor the entire operation. Samples are pulled regularly for texture testing, moisture analysis, flavor evaluation, and shelf life stability. Oreos must maintain their crunch, cream texture, and flavor balance for months under various storage conditions. Accelerated aging tests simulate temperature and humidity extremes to ensure performance throughout the product's lifespan. Food safety is another constant priority. Oreo factories operate under strict sanitation protocols. Equipment is cleaned regularly using clean-in-place systems that flush mixers, pipes, and nozzles with hot water and sanitizing agents. Air filtration systems maintain clean production environments. Workers follow hygiene protocols, including protective clothing and controlled access zones. Allergen management systems prevent cross-contamination between product lines. The scale of Oreo manufacturing is staggering. A single mega factory can produce millions of cookies per day, operating multiple parallel lines simultaneously. Raw ingredients flow continuously into mixers, while finished products exit the other end ready for distribution. Downtime is minimized through predictive maintenance, where sensors monitor machinery wear and alert technicians before failures occur. Every second of operation is optimized for efficiency. Once packaged, Oreo products move into automated warehouses. Conveyor systems transport pallets to storage areas where inventory is tracked digitally. From there, products are shipped to distribution centers, retailers, and international markets. Logistics planning ensures cookies reach store shelves quickly while maintaining freshness. Oreos produced in one country may be consumed halfway around the world within weeks. Sustainability also plays an increasing role in modern cookie production. Manufacturers work to reduce energy consumption in ovens, recycle waste dough, and minimize packaging materials. Water used in cleaning processes is filtered and reused where possible. Continuous improvements aim to reduce environmental impact while maintaining production scale. What makes Oreo manufacturing remarkable is not just the speed, but the precision. Baking, filling, and assembly must occur within extremely tight tolerances to maintain the brand's signature experience. The texture of the wafer, the sweetness of the cream, the alignment of the sandwich, all are engineered and monitored continuously. The iconic twist, lick, dunk experience depends entirely on industrial consistency achieved at massive scale. From raw flour and cocoa powder to perfectly stacked cookies sealed inside familiar blue packages, the Oreo production process is a seamless blend of food science, mechanical engineering, automation, and logistics. Every cookie represents a balance between softness and crunch, sweetness and bitterness, tradition, and technology. And that is exactly how Oreo cookies are mixed, molded, baked, cooled, filled, assembled, inspected, packaged, and shipped on mega production lines. A hidden world of industrial precision behind one of the most recognizable snacks ever created. Thanks for watching The How Factory, where we reveal how the world really works. Don't forget to like, subscribe, and join us again for more deep dives into the machines, systems, and factories behind everyday products.